The wonderful world of chemistry. Acids, salts, bases. Let's begin with acids. What is an acid? An acid is a chemical substance that gives means donates a hydrogen ion. Hydrogen ion means a proton in a chemical reaction. An example is HCl, hydrochloric acid. Hydrochloric acid, when it reacts with a metal, it gives hydrogen, and the metal replaces the hydrogen, forming a salt, NaCl. This is hydrogen. Hydrogen comes out as hydrogen gas. So an acid is a substance that can give or donate a hydrogen ion, which is a proton in a chemical reaction. Hydrochloric acid is an example of an acid. Nitric acid, sulfuric acid, ethanoic acid, and phosphoric acid. All of them in a chemical reaction can donate hydrogen ion, which is also a proton. Now let's learn more about the reactions of acids. When an acid reacts with a metal, it produces salt and hydrogen gas is released. Now here are the formulae of some acids. Remember what was the formula? The formula is how we write a material or a substance using symbols. H is the symbol of hydrogen, Cl is the symbol of chlorine. HCl means one atom of hydrogen, one atom of chlorine in the compound. When you don't see numbers, it means 1. Nitric acid, HNO3. What is the number of atoms in the formula? 1 hydrogen atom, 1 nitrogen atom, and 3 oxygen atoms. Now, pay attention that acids, their name ends with IC, hydrochloric, nitric, sulfuric. Now, acids have names which end with ic. Sulfuric acid is H2SO4. How many atoms in the formula? 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. Ethanoic acid, CH3COOH. This carbon is combined with 3 hydrogen atoms. This carbon is combined with oxygen and another oxygen atom and a hydrogen atom. Phosphoric acid is H3PO4. 3 hydrogen atoms, 1 phosphorus, and 4 oxygen atoms in the formula or in the molecule. Now, when any of these acids react with a metal, a salt results. Now, here is the salt which results from the reaction of this acid. Sodium chloride, the sodium, which is the metal, replaced the hydrogen and hydrogen gas comes out. This is the formula of sodium chloride. Sodium chloride is table salt, which we add to our food to give flavor. Now, this metal can be any other metal, for example, magnesium chloride. That's why we call them chlorides, because their parent acid or their origin comes from hydrochloric acid. Now, what about nitric acid? And when it reacts with sodium, it forms the salt sodium nitrate. Sodium nitrate is in a group of salts which we call nitrate because their parent compound is nitric acid. They all started with nitric acid. Now, sulfuric acid, when it reacts with the metal magnesium, it produces magnesium sulfate, which is a salt. Its name is magnesium sulfate, and it belongs to the group of sulfates because all sulfates, uh, there can be sodium sulfate and magnesium sulfate, for example. All of them started with sulfuric acid. Now, ethanoic acid, when it reacts with sodium, this is the hydrogen which is replaced by the metal. So this is ethanoate, and here is the sodium, sodium ethanoate. And phosphoric acid is replaced, the 3 hydrogen atoms are replaced by 3 potassium atoms, and this salt is called potassium phosphate, belongs to the phosphate salts. Reacting acids with metals. Now, the metal replaces the hydrogen in the acid. Hydrogen gas is produced. The metal and the non-metal in the acid form a salt. Dilute acids react with metals according to their place in the reactivity series. This is the reactivity series. It is arranged so that the most reactive metals are at the top of the series. So potassium is the most reactive metal, followed by sodium, and as we move downwards, the reactivity decreases. So calcium is less reactive than sodium, magnesium is less reactive than calcium, and so on. Now here we put hydrogen. It's because all the metals above hydrogen can react with dilute acids to produce hydrogen gas because they are stronger and more reactive than hydrogen and can replace the hydrogen in the acid. The higher the metal in the reactivity series, the more vigorous the reaction. Vigorous means strong or violent, and you will see some kind of explosion and gas, which is hydrogen gas. So potassium and sodium react vigorously, strongly. That's why we don't add sodium or potassium to acids, because their reaction is too violent, too strong. It can break the beaker where the reaction takes place. What about metals below the hydrogen in the reactivity series? Copper, silver, gold, and platinum. They have low reactivity and therefore they don't react with dilute acids. Magnesium reacts with acids. Magnesium reacts with sulfuric acid. Now, when you add magnesium, which is a metal, to some sulfuric acid in a beaker, you can observe the following. The observation is what we observe, what we see or smell or hear. First thing, there is rapid whizzing, which is a sound. And then there is a colorless gas which evolves. If you put a lighted splint شعلة شعلة قربت تنطفي. If you put the lighted splint near the gas, it pops. It makes a sound, pop sound. This is the test for hydrogen gas. Therefore, this gas which is evolving is hydrogen gas. Magnesium gradually disappears and the solution becomes colorless. The solution is magnesium sulfate. The conclusion means the explanation of our observation. Magnesium is more reactive than hydrogen because magnesium is above hydrogen in the reactivity series. Therefore, magnesium displaces the hydrogen in the sulfuric acid, forming magnesium sulfate and hydrogen gas. So the magnesium, the metal, displaces the hydrogen, and then magnesium sulfate is formed. Magnesium sulfate is colorless.